for flood management using Flood Intelligence Service tool and water field barriers, the SLAMDAM. And I would want to take this opportunity to welcome our speakers. We have Mr. Richard Musota, who is the Acting Assistant Commissioner for Water Use Planning and Regulation in the Ministry of Water and Environment. We are also going to have Mr. Robert Bogere, who is a Senior Hydrologist in the Ministry. I'm called Dr. Kalisti Ndumugaya. I will be making only the opening remarks. After that, Richard Musota will handle the session, and then we shall come back at the end towards the closure to give some final remarks. Otherwise, I want to welcome you and thank you for attending this webinar, and I hope that we shall enjoy it. Maybe before I invite Richard to take the floor, I just to inform you that these monthly webinars are held every last Friday of the month. But for this one, we have decided to handle it early since we are going for Christmas. But I want to request those of you who would want to share to inform the Secretariat at the Water Resources Institute so that you can be scheduled to make your presentations. We use this opportunity to inform Ugandans, to inform the world about the good work we are doing so that we can learn from each other and also be able to inform decision-making at the lower level. Otherwise, thank you very much. And on this note, I would like to invite Mr. Richard Musota to take the floor. You will also handle the Q&A, and then the Water Resources Institute team will come in towards the end to close. Over to you, Richard.
Thank you, Dr. Kalist, for the introductory remarks. I hope I can be clearly seen.
Yeah, we see you and hear you. Go ahead.
Okay. So I'll be making this presentation jointly with Mr. Bogere Robert. I wish the admin to allow me share. Now have sharing rights. So as that is being enabled, we shall do this in about 3 parts. I will do the general introduction of the presentation. And also we shall be having a case where we've piloted this. This is in Obongi district, in a place called Waka, and it is found in a Koch sub-catchment in Albert Nile catchment. But Albert Nile also is a basin, one of the 8 basins in Uganda. So that's where we had the pilot. So I'll do the introduction, and then Mr. Bogere will come in with the application of the tool, which is the Flood Intelligence tool. And then I come in to look at the Flood Intelligence Service tool that evaluates the impacts of flooding, but also impacts of interventions that have been undertaken. So that will be how we shall be handling this, and we hope it will be interesting to you. So this is what we are, and we immediately get going. So our outline is we shall have the introduction, SLAMDAM project in Uganda, then the SLAMDAM intelligence suite. This is a set of tools that are applied. First of all, the hydrological tool, and then we have the SLAMDAMS themselves, and then we have the evaluation tool. Then we shall go into the details of application of this SLAMDAM intelligence suite at Waka in the Koch sub-catchment. And of course, to take us through the simulation, site selection, and then we go into the characteristics of the SLAMDAM, which is the application bit of it, physical application on ground, and the deployment process, and then evaluation of the impact of deploying the SLAM dams, and then after that we shall conclude. Technology is failing me. I can't navigate. Okay. So as a matter of introduction, we are all aware that I hope you can, because it had refused to move. Are we in? Are we there?
Yes.
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 Yes, we can see. Thank you.
I can't hear you. I don't know whether you're still there.
Yes, members.
Yes.
Is the presentation going on or there is a problem?
I think you've been having a network hitch, but we are trying to sort it with the IT.
Okay.
Yeah. So are we back? Are we visible?
You're not displaying anything.
Okay.
Yes, we can see the screen.
Now we are back.
Okay.
So this is the presentation outline that we shall be following. And I think we had gone through this. I don't know whether at this point in time you were still with me.
We were with you. You had gone to the second slide.
Okay. Now I think we are able to flow. So as a matter of background, we know that 98% is transboundary, and with 69% of its renewable waters coming from outside its borders. This places Uganda in both a downstream and an upstream situation. But with regard to receiving water resources, you would classify it more as a downstream because it has a lot of it coming in. And by virtue of its fact, and given that 15% of Uganda is open waters, then this, with increased water inflows due to climate change, implies that we shall have recurrence of flooding in many places being more frequent. So as Uganda and as our placement, the risk to flooding is relatively high. And in 2021, we realized that we got the highest ever recorded water levels in most of the water bodies that we have in Uganda. And these records have continued since then to be broken. For example, in May this year, Victoria again recorded a new high of 13.77 meters as per our gauging station at Jinja. So according to the country climate risk assessment report, Uganda is ranked as 27th most vulnerable and 25th least ready country to address climate change. The risks of climate change or hazards, the most pronounced one that we receive most frequent is flooding. And the maps to the right tend to indicate areas that are prone to flooding in the country. And you can see that majority, almost 30% of Uganda is actually prone to flooding. And the economic annual loss that is related to this is estimated to be in excess of 62 million. I hope these were not even $1 billion across the country on an annual basis. So based on this, we were able to craft a project as part of the small innovation grant at Adaptation Fund. And this is a part of the climate financing, which was successful and was funded. So the project in itself is enhancing resilience to climate-induced flooding and drought through the development of a water-filled barrier in Obongi. Now, the water-filled barrier is the innovation that we bring on board here. And it comes with support tools that help the pre-assessment of the flooding, and then the deployment of the water-filled barriers, and also the post-assessment of the impact of these water-filled barriers once they have been deployed. So this is what we shall be looking at. And the project objectives were to introduce SLAMDAM as a cost-effective and efficient solution to mitigating flood risks. And we shall see later how possible this is. And also to enhance community resilience to floods through practical, adaptable, and sustainable measures, and to demonstrate the viability and scalability of this innovative management technology in Uganda. So this will be our basis of discussion today. A little more about the project data regarding this innovative innovation project, which is a small-scale grant at Adaptation Fund. So the funder, as I've already said, is Adaptation Fund. And the innovation grant was up to $250 million. Initially, it was supposed to be implemented within 6 months, but it took longer because we had to go through the process of manufacturing these SLAMDAMS, and then they are lifting them from Netherlands to here, and then the deployment. So the implementing entity is Ministry of Water and the Environment, and the executing entity, Ziffer Consulting Limited, is a Dutch consultancy firm that we worked with to put together this project and also to see it implemented. And the implementation area is Obong in northern Uganda, and this is located in a Koch sub-catchment in Albert Nile catchment. So this is where the project is located. So for now, I will let it at this, and then have my colleague, Mr. Robert Bogere, come in to take us through the Flood Intelligence Suite, which is a collection of tools that we use for assessment, action, and also evaluation of the impacts. Thank you for now, and over to Mr. Robert Bogere.
Yes, thank you, the Assistant Commissioner. And once again, members, I'm by the name is Bogere Robert. Just as my colleague has mentioned, the SLAMDAM Intelligence Suite is a collection of tools used for assessment and then management and evaluation. My stake will basically rely on, and as you can see on the PowerPoint, the tools helps analyze the anticipated flood risks, assesses the appropriate response technology, and where to place the management technology. It basically consists of 3 components. The 3DI live site, this is like a model. Those are hydrologists, or those are the water resources managers. Then that model is inbuilt in a lizard, in a lizard viewer. The lizard viewer is like ArcGIS, but also it can act as a Google Earth engine. since it uses data within the cloud system. And then it has, after viewing, it gives you the place where to put the barrier. That is the SLAMDAM for this case. But before you press the barrier, you assess what was the impact of the flood. The flood, what economic losses was it causing? Then after pressing the barrier, you can again be able to assess the impact. Have you reduced the magnitude of the flood? Have you reduced the economic losses? So the Flood Intelligence Service, the FIS, is done pre to pressing the barrier and after pressing the barrier. Then information management. Within that intelligence tool, within the intelligence system, information management is important. Just as we could be aware that for reliable assessment, data is essential to design best interventions. Within this innovation or within this intelligence, that one is encompassed. Just like other countries on the globe, Uganda has limited access to data. So this one, because it has the component of accessing the data in the cloud, it gives the tool an advantage compared to other tools. Just as you can see, you can access the data. After accessing the data, you can locate where to place the intervention and then assess the impact. What has the intervention done? We can look at briefly the 3DI, which is acting as the model. This is just like a class actually. It is a hydrodynamic model which was developed by Neren and SCAMS. It has the ability of the art of modeling. You be in the office and model what is happening, for example, where you are not on the ground, like the way we did for Waka. It can model the fluvial and coastal floods, and it can also be applied both urban and rural areas. It has a combination of fast simulations, interactive modeling, and it schematizes the river and then capability to model the hydrodynamic processes which happens within the hydrological cycle. It comprises some of the data inputs in the model. When you are modeling, what can you be interacting with? You'll be interacting with the raster terrain, which can be like the dam, just to fuel the floods and the rainfall runoffs. Then you can also have the raster soil, the soil data, and then you can be able to a 1D open water canal system. You view the water system as the river may be. If you are applying it at the urban setting, then you'll also be able to see the sewer network. Then this is the model. But when you are interacting with the model, you are able to view all of the interaction is what you are doing in the lizard viewer. Just as I've said that this lizard viewer is acting like ArcGIS, however, compared to ArcGIS of accessing data within the cloud system. So there it is behaving like a Google engine. It's designed to store vast amount silos and integrate data sets into one platform. The data warehouse is designed for the quick review of data. This allows you to easily combine data in analysis, produce reports, and then offer the advices. All data is stored, and you can decide to share it or to keep it, whatever you may decide. For us now, we are sharing. Then, after understanding, we went ahead and applied it to Waka. And this is the slide talking how we did that. First of all, Upper Nile Water Management Zone, just as it has been displayed. We've been having many water resources studies, and we had done we had mapped out the key flood prone areas, just as they can be displayed, just as they are being displayed on the slide. So our first insight was to review data review, to look at what were the areas, what areas do we have which are flood prone, and that was done as a desk review. Then after that, we went ahead with the analysis, and we selected Obonji as one of the vulnerable districts to floods. And then we visited Obonji, but before that, we visited 3 sites. As you can see, those sites being highlighted by yellow dots, 1 up to 6. We visited those sites, looking at both the requirement for placement of the technology, and also which sites are more vulnerable, and what economic activities are there, such that if facing the barrier, what are we protecting? We found that after comparison, we found that number 3, the worker was more appropriate. Then, when you look at number 3, it involved basically 3 sites still, after visiting all the 6 sites, with rocks to Waka, Foligo, and Wanamich as the flood-prone areas within Obonji district. Then we ran the model with a size of the coach sub-catchment, roughly 1,600 square miles. We delineated it, and then ran the model to see the inundations. And on the right-hand side is depicting what was the model output. And then, just to select a sample, we tried to carry out this with a rainfall event of 50 millimeters per hour, but for 2 hours. What would happen? And after 1 hour, we see that the inundation is the catchment is okay. Then as hours increased, you could see that infiltration, seepage is occurring. And then you could see that after 24 hours, the lighter picture in the lower right-hand side, that is after 24 hours. So you were able, within the model, you were able to see all of this, the interaction, how the catchment respond to rain. You were able to see that. And we tried all that in Waka, Foligo, and Wachiraminji. Then also, when you could see simulation, the inundation is, just as I said at the start, this is like HMS oil class. You can even see those who have ever used that model. You see that the pictures, the images, the way they come out, they are similar to the other one. So on the left-hand side, those are inundation depth. The model will see the inundation but also it gives also the depth. And then it can also give you the flow diagram.
So Francis, can you check what has happened?
We are back. I think let's try to reshare.
Okay.
I don't know where we got lost from. And now we have to go back. I think I've been talking when I'm off. I have to ask them.
This one is not. Can we be seen?
I see
Hello?
the slides are
Yes.
seen.
I see now.
Where
Eh?
did we?
Where did you lose us?
On the flood simulations at Waka.
At work, that's where we are right now.
So I was just saying that the slides are showing simulations at Waka, and I will request members to take a note how the intents of those pictures are appearing. The slide. I think network is not clear.
Can you hear us still? We are having challenges with.
Yeah, you're so loud and clear. Please go ahead.
Francis, can you help the team on connection? I think with Francis, can you help the team? They can change also the network in case that one is not good. Otherwise, we are cutting off.
Share. So let's try to improvise the internet. And then we get back with okay, we may continue with this. We can't move the slides. God.
Sometimes you leave. Why connect to mine? Let me connect to mine. Sijana. So nilikuwa disconnect.
What's the problem? We are connected to. You use your phone. Just put your phone when you start it. That comes it is. Okay.
Colleagues, hold on. The team is trying to sort out the connectivity. Just bear with the team. We will be back shortly. They are getting some assistance.
Yes, now we are back.
You hold on there and see. Otherwise, people will run away.
Now, what's that disabled share?
We need to be allowed to share.
Where is Francis need to allow us to share?
So you need to be allowed. But did we sign out? Richard and Robert, are you ready to resume?
Yes, we are ready, but we need to be allowed to share.
You are not able to share.
We can't.
We don't have audience open. Robert, can you try to share? See whether you can share now. Are you able to?
We are still locked.
Are you able to share?
Not yet. The sharing is still disabled. Okay.
Can share now. Yes.
So proceed,
Are we
please.
okay?
In full presentation mode and proceed.
We are there. Hope we can be seen.
I think
Yeah,
I think now
proceed,
the
we see the
PowerPoint
presentation. You proceed, we see the presentation.
Yeah, thank you. And sorry for that setback. We're at simulation is at Waka, where we could see the flow direction is, but at the same time, you can also view the flow accumulation is, the inundation is, sorry. Then that is at Polygo and at Inamich. You can see in this slide that this is a comparison of the simulations, and clearly seen that at Waka, the flood inundation is looked to be denser compared to Wanamichi.
I think there's a big problem here. What type of internet is this? The presenter cannot be heard. I hope everybody else is here. No.
Richard and Robert, we don't hear you. Can you check your connectivity?
Can my slides be seen? Yes, we can see them very well. It had gone again off. But,
What are you using?
the phone now.
So, but is the phone on?
Yes.
No, the phone is on. Yes.
We are back. So we are moving into the flood management measures using SLAMDAMS as part of the innovation methods. We've been run through the hydrology, and we've seen how simulation of flood inundations and the extent is done using the 3DI and the lizard softwares. Now, this is the other component of where we now need to undertake interventions. And what we are using are SLAMDAMS, and SLAMDAMS are rubber containers that you can fill with water and then lay them out there to mitigate against flooding. It is an easily deployed mobile water barrier, and it has been tested to be efficient in mitigating flooding, but also as it mitigates the floods, the water that is stored in there can be used in the future for either irrigation or other water use requirements. It is very adaptable to changing environments and creates immediate impact, and also is very suitable for emergency response. So in areas where you have to react quickly to flood management, SLAMDAMS are very, very, very effective. And sorry, again, I can't navigate through my slides. Okay. So what are the unique features of SLAMDAM? It consists of two compartments that press against one another. And once you put in water, then they are able to press against one another, and they become air and water tight to flows. So you won't have water flowing through the joints, and this one will help in attenuating flood effects. And it is made of rubber, of that polymer, ethylene propylene monomer. It is a biodegradable material, so that is one of the nice properties about this. It can be tailor-made, so you can design and manufacture SLAMDAMS according to your flood levels and also the flood extents. It is not affected by UV light. It is very tolerant to that, and once you store water in there, you are sure that the water properties will not change a lot. And it has a lifespan of about 40 years. So these are the characteristics of the materials that I want to use out there. And therefore, it is a friendly environment and also quickly adaptable. Now, if you are to deploy these SLAMDAMS, there are things that you need to take into consideration. And we've categorized them into infrastructure or logistics, ground conditions, the strength, and also the dimensions. So, under infrastructure, and as you prepare to deploy, you need to know what is the lead time of a characteristic flood event. So what is the minimum time that is required to be able to deploy these SLAMDAMS? And then, of course, since they are water-filled barriers, once you put them out there, you will need water to fill them for them to be functional. So a readily available source of water is something that you will need for you to be able to utilize these materials. But you also need to know how they can get transported to the site. They are not heavy materials. I think they are carried in boxes, and each box is approximately 50 kilograms. So they are a bit flexible in transportation, and they are deployable and demobilizable from the site once the flood has gone. So after deploying, you can be able to pack them again and go and store. For the ground conditions, they are not suitable for steep slopes. So gentle slopes are more preferred. As you've seen in the picture, if you put it on a steep slope, then the possibility of it rolling over is high once it is pushed by water. Then the soils on which you are placing them, they should have limited permeability. Otherwise, as you deploy them on top to manage, it will continue to seep underground. And you also need it on a ground where there are limited sharp objects. And then where you are deploying them also, when you have occurrences of very high velocities, these ones, standard sizes are about 5 tons, that's about 5,000 kilograms. So if you have very fast flowing water and they encounter this body, they may dislodge it. So they are not also suitable for areas where there are high currents of water that are flowing in a river system or a water course. And the dimensions are flexible. You can order according to how you want to deploy them, but standard is 5 meter length and 0.75 meter height. But you can get flexible length and height for the SLAMDAMS. So based on those characteristics, we evaluated the 3 sites in Obongi, but there was also an additional site in Elegu. So Waka, Forigo, and the Ekiniminji, I think it will be the areas where we shall concentrate. From the simulations, we did realize that at Waka, the flood depth was about 0.5, same for Forigo. And then Ekiniminji, the flood depth was 1 meter. This is at a 1-year return period, but we also did a simulation for a 40-year return period. And we discovered that at Waka, it would most likely be 2 meters, Forigo 2 meters, and the Ekiniminji would remain 1 meter. And the velocities of the waters at these various sites, at Waka, it was found to be relatively low, since it is in the floodplains. Same for Forigo and the Ekiniminji. And then, of course, the flood return period, this one is annual. Actually, every year they experience this flooding. But when this flooding occurs, at Waka, it tends to stay longer, up to about 14 days. Whereas at Forigo and the Ekiniminji, it is approximately 7 days. So we found that, and what we saw from the pictures, that Waka is more vulnerable, and the flood impacts are a little bit higher. And this is how we came to zero in on Waka as opposed to the other 2 areas of Forigo and Ekiniminji, but of course both in Obongi. So we went ahead to pilot the deployment of these dams at Waka. And what did we go through? To the left, we see the boxes. The boxes contain the SLAMDAMS, and to the right, those are the SLAMDAMS. And these are the communities that were being taken through the process for deployment of these water-filled barriers. And in that picture to the right, at the extreme, if you are careful, there is River Kochi. This is the site where we're trying to protect breaches of this river once the water levels raise. So it is the very water that we are pumping into the SLAMDAMS to have them work effectively well. And it was just a one-day training of these communities, and they were able to cope very fast and implement the deployment of these SLAMDAMS. So this is the process of deployment, the pumping of water into the dams, and of course, now the alignment along the riverine at the area of breaching. We were able to deploy this at a stretch of 100 meters long. And now this was at a later stage. You can see bushes starting to grow around it. This was an evaluation of post-deployment. They were still intact and fairly functioning well. And there had been reports that floods had come, and they had been able to at least mitigate the impact of those floods. So this was the process of deployment of the dams. Now, after deployment, we as well tried to do an evaluation of the impact of these dams. But generally, the criteria that one needs to look at as you evaluate the impact of these dams is, of course, the people, property, and of different types. Yeah. So you have buildings, you have agriculture, you have animals, then risk to diseases. So this parameterization of these different elements, and of course, which can be obtained through also remote sensing using satellite images. Of course, the people will not get them from satellite images. This one you can do the count and populate, but the other elements are generally physically based, and they can be got from satellite images, quantified, evaluated, and then fed into the Flood Intelligence Services tool, which we call the FIS tool. So in the FIS tool, key to that is that as you start, you need to do a selection of the area. But of course, if you've done the other prior 3 DI and lizard analysis, of course, the site selection has already been done. You've done the evaluation of the flood depth and the flood extent. So it is that layer that you will come and feed into this Flood Intelligence Service tool, and then populate it. You select the flood type that you want to deal with. And here we're using a 1 in 10-year flood event that was selected for Waka. So once you've selected that and you fed in your area, now here the key thing is that you are looking at the parameters or elements that are likely to be affected by the flooding. And this is where remote sensing comes in handy to be able to evaluate what kind of land uses we have in the area that is commonly inundated. And you said in a separate tool, you do the economic evaluation of those different elements, but also the quantification of their sizes. So size and the price, and you get the economic price, and also the social value that that thing has got. So these layers are now fed into the FIS tool, along with the flood extent inundation. So this is just going through what you need to evaluate your area that is likely to be inundated, and what properties you have in there that you are going to cost. So once you've been able to cost these, then you bring in your hydrology to try to optimally locate where you can put the SLAM dams to be able to mitigate the floods. This was a simulation still at Waka. Situation where no intervention has been done, but if you look to the right where we have a red line, this is part of the deployment of the SLAM dam and the impact that it has created, because you see some slight reduction in the inundation area of the flooding. So once this is done, the tool automatically calculates what residential area has been damaged or has been inundated, and what was the costing that is associated to that. So there is the baseline, which is before and then after the deployment. And here we see a reduction from 9.2 to 5.8, which gives a net benefit of 3.3 million euros. So it is similarly done for the other land use properties within the area that is projected to be inundated. So using this, you can quickly evaluate, first, what will be the impact of the flooding itself if no action is done, and also what will be the impact of the interventions that you've undertaken after the flooding has taken place, and then the net benefit that you get out of that intervention. And this can be done through so the biggest work is in trying to quantify the assets in there, and also trying to cost them, as well as doing the hydrological setup of global models clearly well. So these are just visualization elements of the impacts of what you've undertaken. Here we see reduced land areas impacted by floods, and also the number of people that are impacted by the flooding. And you can also, as you present your results, you can be able to disaggregate it into the different classes. You can be able to disaggregate women and men. You can have impacts of buildings, trees, water, vegetations, and all the other land use classes that you have within the area. So this is how the costing bit of the Flood Intelligence Service tool really works. Of course, after that, after we had done all the interventions, then we went in to try to do a monitoring and evaluation of the impacts of the technology itself, and also the acceptability by the people in there. So we've tried to do a quick survey and interviews within the communities, and the results are that there is effectiveness in the technology, and also adaptability is seemingly easy, and there seems to be buy-in by the communities in these areas. So as a matter of conclusion, SLAMDAM technology is suitable and easily adaptable under emergency situations. But of course, we've already given the limitations of these dams. They are not usable everywhere. For areas where you have gentle slopes and you also have not very fast flowing water, they are effective. So upstream is a limitation. Downstream, probably, yes, that is what I think what can be a key message in probable use of these SLAMDAMS. And of course, now this package, the Flood Intelligence Suite, enables you to do quick evaluation of before and after, but also quick characterization of your catchment. Once you've calibrated it, then it is a question of trying to feed in. If I had this rainfall intensity, then what is likely to happen to the area of focus? But bottom to this, to have this technology succeed, you need the buy-in of the communities, because they are the ones that are responsible to see that the dams are deployed, and where they are deployed, they are not vandalized. And if they have issues of maybe puncture, then they should be at the center of going into repair. So it is not a technology that you are going to operate from a distance. It must be integrated within the communities. With that, we come to the end, and we thank you for listening in. Over to you, Chair.
Richard, you will moderate the Q&A session.
Chair, I'm the one receiving the questions. I don't know if there is someone who can help moderate as we receive the questions.
No, you moderate, then Bogere captures the question, then you will handle.
Okay.
Just receive, and then the other one will revert here. Just
Okay.
do that.
Robert, we have some questions already in the chat. Maybe we could start with those ones.
Robert and Richard, can you respond to those which are already in the chat as others come? Richard and Robert, are you there? We wanted you to respond to the questions in the chat already.
Sorry. We were responding when we had muted ourselves.
Yeah,
So it is, SLAMDAMS are made out of biodegradable rubber material, EPDM. It is an ethylene propylene diamine monomer. So it is a polymer that is used to manufacture these dams. And key is that it is biodegradable, and it also lasts long, and it is also resistant to UV. And the next question is, what is the appropriate distance between water line and SLAMDAM placement? I think Robert will take on that. And then, how does soil type in the river bank affect SLAMDAM effectiveness and efficiency in flood control? Okay, so for now, I think we shall have Robert respond to those two.
Thank you. I'm taking over the question, what is the appropriate distance between water line and the SLAMDAM placement? Just as said before you place the dam, you do the assessment. The assessment is it is involving both the modeling and the field assessment. Reaching on the ground and getting the information from the community. Just as you agree with me, scientists, that when you are when you are carrying out any study, information from the community is very vital. So these people will tell you the highest flood mark of that river. Then it is a guiding point. But remember also, when you are doing the inundation modeling, you can see the extent of the inundation is. So when you got the field, you are just verifying what the model gave you. Then that one will mark the distance or the line where to start from when you are pressing your SLAMDAM. Then the next question was?
Maybe I can as well add to that, I think Robert has taken it up in two perspectives. One, you need to know the area of breach where the water breaks the river banks. So there is the length that you need to plug, that one you need to assess. But how far off the river or off the water body, that one should be as close as possible to the water body, because what you are trying to do is to increase the height of the either lakeshore or the river bank. So what is needed clearly is the ground on which you are placing your SLAMDAM even enough, and if you place it there, is it likely not to topple into the flooded area itself, rather the river or lake water body? So it can be as close as possible. And for this, I think we did it at about 10 meters off the river bank, just ensuring that the ground is stable enough.
Then the next question.
The second question was,
how does
how do the soils, how does soil type in river bank affect SLAMDAM effectiveness and efficiency in flood control?
The soil type in the river bank, just as Richard has said, Richard has just said that when you are pressing the river bank, you have to make sure that the ground where you are putting it, one, it is flat, two, is stable. So the soil shouldn't be so soft. And for our case, when we were deploying, we had even to hire an excavator, which came and stabilized the ground. So basically, the soils must be stable. But maybe if the question was referring to the modeling perspective, we all know that soils are a component or is a function of seepage. So that is why the model requires the data. And one of the requirements is the soil type.
Okay, but the base on which you are placing these SLAMDAMs, of course, you may get soils that have got a lot of debris in them, and therefore water can easily percolate under. So now if you have such soils, you may need to do a bit of compaction so that you know that once you place the SLAMDAM, you don't stop the water from passing over, but it is passing under at a relatively high speed. So you need a well-compacted soil where seepage under is also greatly minimized. So where you have clay soils, yes, that one is the best, but of course, flooding is not going to only look for where you have suitable grounds. So the message should be that if seepage through the soils will be high, then you do a bit of compacting to ensure that that seepage is minimized. I think we still have more questions in here. Can you throw more light on the cost of the technology? Can you throw more light on the cost of technology in terms of areas of control, including acquisition? Now, here we can talk about the cost of buying a meter of SLAMDAM. This is relatively a new technology. It is not so much out on the market, so it is mainly under pilot. It is not yet at very commercial levels, so the costs are still high. So you come to a meter of this thing goes for about, it was coming to about $200, which is a bit costly. But they are trying to get to commercial levels. So most likely, as it is marketed out more, the cost may go on reducing. But remember, it is $200, but it is something that you can use over a period of 40 years, as long as it is protected from being punctured. When the flood is there, you deploy. When it has receded, you can remove it and go and store. So those, but it also comes with, if it is punctured, there are repair kits that come with it, and they are easy to repair. The way we mend the tires is the way you are going to mend these SLAMDAMS. Does salty water have effects on SLAMDAM? No, they are really robust and can withstand saline conditions. But also temperatures of up to 120 degrees Celsius. So sometimes there can be a fire out there and it will survive.
What steps were taken to calibrate and validate the model? Just as you could construct a class model, you pick a one event of rainfall briefly, input, and see how the hydrograph would behave. This is also what actually is done. You just look at the hydrographs and see how they are coming out compared to the observed hydrograph.
Okay. So it is standard methods that you use under hydrological modeling for calibration of models. This one is just a quick one to help you focus on flooding alone. But I think the procedures are the same that you take when using other hydrological models.
A comparison of SLAMDAM intelligence suites with other common tools like HMS, so the tool is not an open access it. So I am yet to find out, and maybe I'm yet to find out whether academic institutions like universities can also have access to that tool. But for us, when we were doing this, we could access, and up to now, I still have the rights.
But I should also say that we have one of the persons behind, the brain behind this technology, Mr. Omar Saleh, is online. So I think we shall also at a later time give him some space to speak more about this SLAMDAM technology. So Omar, please feel free to come in as when required, though we shall reserve some slot for you at a special moment. But as we react to the questions, kindly feel free to supplement our responses.
Thank you, will do, but you're doing already a great job, Richard and Robert. Thank you.
Thank you. Next one is thank you for the presentation. Was the height of the SLAMDAM determined from probable height of flood, or is it a standard height? For this, we used the standard height, but when we were doing the assessment, you remember at Waka, we said that the flood depth was about 0.5 meters, and this was within the standard parameters for the SLAMDAM. So that is what we considered.
But maybe to add on, just as Richard said at earlier stage, that if you are taking it up to another site and you've done assessment, you can place your order depending on what parameters have you got on the ground.
Okay. Then we have seen a number of flash floods at Pakwach Bridge due to River Tangi bursting its banks. Can this technology also be adapted in such instances? It is a no and a yes. Yeah. One is that one needs to do a detailed analysis on how this flooding occurs and how it behaves. But we also know that this site is a little bit at the lower side. It's a bit flat. But also the causing of the flooding at Tangi looks to be more of a constriction, meaning that there is accumulation at the back, and it also sometimes acquires a bit of high heights or depth, I could say, because once it accumulates, you've seen always that it builds up really heavy at the back. It is presumed that sometimes it is even in excess of a meter. So given the volumes and also the height that it attains, it may not be possible to use this. There is a risk of toppling this, but we've also seen that the force that this water comes with has even been able to take trailers that are about 30 tons. So it may not be very appropriate for an area like what happens at Pakwach, resulting from the flooding by River Tangi.
But on the perspective of a yes, the technology of the SLAM dam works appropriately together with a combination of other flood control measures. For example, for Tangi, personally, I've ever been in the field assessing the causes of the breakage or the flooding in Tangi is a constriction, as Richard has said. So assuming we've worked on that constriction, UNOLA or Minister of Works is now connecting with Minister of Water, and we've opened up. Now, if it happens that upstream, the volume of the waters are still coming, that damming which is always caused, you can leave that damming, you leave that basin, then you put the SLAM dam at the edge where the water usually stops. Maybe there you'll be protecting, for example, maybe the park or the upstream this side of now Pakwach town. So it can work, but it cannot work solely. Thank you.
Thank you, Robert. I saw there was a hand by Waswa, but let's first exhaust what has been put in the chat box. This one is requesting for recording of the presentation. I think management at the institute will do that. Do we have any challenge of vandalism by the local communities for the materials? So far, not yet. It has so far worked well with the area where we deployed it. We said there was good reception by the communities, and once we deployed, the impact was almost immediate. And also the timing of the deployment, I think on our side was good. We deployed then within a period of a week and a half. I think the river was very full, and for that section where we deployed the dams, we didn't have the breaching of the river. But of course, downstream further, the flooding still occurred because no intervention had taken place. So we've not yet faced vandalism, and we hope this situation will remain. And we will continue to receive feedback from the communities. Now it is getting into a dry season. They are talking of demobilizing the materials to be stored in a safe place to wait for the next cycle of flooding. Thank you for the presentation. What is the level of uncertainty associated with the tool during hydrological simulation? Robert.
Just like any other model, all models have uncertainties. So it depends on the data you've input into the model, and also the expert using it, just as always any model that garbage in and garbage out. However, if this model is properly and you have the correct rainfall data and also the expertise, because just as you were seeing that when you put rainfall intensities of 1 hour duration, 2 hour, so you must know how to and this rainfall data which is collected is always in 24 hours. So you must know how to do to break down those the rainfall data into intensities of the required hours.
Okay, so breaking down the rainfall into
The
required intensities is key to having this model safely operate. That is what we've had in the chat box. Now we will open it to online comments. There was a hand by Waswa. I don't know whether he's still in.
Yes. Thank
Yes.
you. Thank you, the presenters, and thank you, the minister, for organizing these informative sessions. I was just wondering whether this technology can be applied to the shores of Lake Victoria or other lakes in Uganda. We are seeing water levels increasing. Thank you.
Okay. Actually, I think straight away to the shores of lakes, that is where it is most effective. Now, the challenge is the span that you have to work with. So if you have a span that is limited, where water tends to escape from the lake shores to flood specific areas, then there it might be cost effective. But if the span is too big, then elements of cost come in. But the technology as in itself, for such situations, actually lake shores, it is where it would work perfectly well. So it would be a question of the span and how long it is that you need to be working on to protect the flood-prone area. Any other question? You may feel free to unmute and make a submission in case we don't see your hand up. Is that all we've heard from you? If yes, then I may call in Mr. Omar Saleh. Omar Saleh formerly was with that Zephyr company, but now it is transited into web servers and is the brain behind this technology and marketing it around the globe. So far, we are having it in the East African region being implemented in Burundi, Kenya, and Uganda. So Omar, you may come in for some remarks before we give back to the chair for closing.
Thank you, Richard Roberts, for the clear presentation. And yeah, I hope everyone enjoyed it as well. I think you explained quite well what SLAMDAM can do. And indeed, we have done projects in Burundi, Uganda. Burundi, we're going to scale up. Kenya as well. So we're quite active in Eastern Africa. And I think there are a wide variety of conditions where SLAMDAM is effective, at rivers, lakes, I just heard as well. Even coastal areas, we are using SLAMDAM at the moment. And I think it was the project in Uganda was also successful with the help of the local team and the ministry. I think we've been able to showcase that SLAMDAM is was effective there as well, and also to the satisfaction of the Adaptation Fund, who have expressed their gratitude and they're quite happy with the outcome of that project. So at the moment it's being developed in the Netherlands. We're actually exploring also an opportunity to start manufacturing in Eastern Africa. Not sure where yet, but I think that would help if we are going to scale up, also cost-wise, because now it's being transported from the Netherlands, which has some more cost. But I think if we can do it regionally or locally, then we can save some cost as well. And maybe to highlight as well, I think one of the main advantages of SLAMDAM is that many countries are using it dual purpose. So for flood resilience, but also for water storage. And an example is in Burundi, where this community, they're using it during rainy season for flood prevention, but during dry season for water storage. And actually they have been able to double agriculture production. And that had a ripple effect because incomes doubled, child malnutrition decreased, better access to healthcare, better access to education. So that had a huge impact on that particular community. That's also one of the reasons why the UN has selected that project to be scaled up out of 200 candidates. So we see a large uptake in all over in Africa, Eastern Africa, and hopefully also there might be the potential to scale up in Uganda. But should you have any questions later on, I'll drop my email in the chat. Then you can always reach out to me. Happy to share any information you would like. Thank you.
Thank you, Omar, for those remarks about SLAMDAM technology. And now, if there are no quick comments, observations, questions, then I will call upon Madame Gwendolyn Chobrunj to close. Waswa Peter, you still have a comment?
Yeah, maybe, sorry. I saw you evaluate the benefits of using the SLAMDAM, but did you also went ahead to quantify the environmental impacts in a negative way associated with the SLAMDAMs? Thank you.
Thank you, Waswa. Actually, at the point of deployment, of course, the where we put the SLAMDAMs and where the river was breaching, there was thick vegetation. So we had to do clearance of vegetation to be able to lay these dams. And when we shared those pictures with colleagues within the ministry, there was big concern. And you say you are doing environmental protection, but again, you are clearing. So sometimes you cannot eat your cake and still have it. Those are some of the negative impacts that you will have to contend with. But also we are saying this is a biodegradable material, but of course, after those 40 years, it is not just going to turn into soil immediately. It will be somewhere out there in the environment before it is finally totally assimilated. So those are some of the elements that you can look to as negative impacts to the environment. But when you look at it overall, I think the benefit outweighs that. And as I showed you, still in the pictures, much as we had cleared, a few weeks after deployment, you saw the vegetation had regenerated along that riverine and within the dams where they were deployed. Thank you.
Richard, may I add one thing?
Yes, please.
Yeah, so it's a fair question, by the way. So quite often we also do environmental social impact assessments. And if we have a bigger project, to understand what will be the impact. In general, I would say that other conventional measures, like building a concrete dam or a channel, normally has a bigger impact on the environment than SLAMDAM. I think one of the advantages is that you deploy SLAMDAM and then you can remove it again. So actually, we try to harm the environment as less as possible. So yeah, that's my experience, that our impact is less than that most of the conventional flood resilience measures. Thank you.
Okay, thank you, Omar, for that clarification. And if there are no more questions, then I will. Yes, Hassan.
Thank you, Robert and Richard. My question is about the stability of the models. Given that we have had in about a year, the past year, probably a little longer, we have had 10 years worth of warming at the previous rate in just 1 year. So when you're doing your assessments, you have you say for example, you assessed it at like, a 1 in 10 year event. So that means that the reality is changing. So I wonder, like, how are you thinking about that, and how fast are the models coping with the rate of change, increasing rate of change?
Okay. Mr. Dennis Wire, I see your hand is up.
Okay, thank you so much for the presentation and the wonderful research that that is ongoing. My part was on, you were talking about the degradation part of the material. I had this in mind, that there's a possibility that we can actually do the modeling to understand the degradation of the material and its impact on groundwater, and also the half-life. It could be possible.
Okay. I will call now Robert to take on the first question. We are in changing times, yes? So how quickly can these models also be used to simulate these changes that happen?
Yes. Basically, the model here being used is just a rainfall runoff model. What it is doing is to show you what happens to when an event of rain is received, what happens, how does the catchment react. So if you are to do to incorporate the changing situation, then you need to bring in the component of climate change. You build the scenarios and then again input into the model. Unfortunately, that was not done, but from the background Richard gave, showed that and also from literature review of many scholars, it is evident, clear that predictions show that impacts of climate change, they are increasing. Floods, flash floods are on increasing rate. Also, the drought side is also increasing. So the model just helps us to locate the position where to put the intervention. And it is the intervention which is acting as an adaptation measure to the changing situation. Thank you.
Yeah, but also if you have your model well calibrated, and now the only value you are going to have is the rainfall intensity. Yeah. So as it changes, then it should be able to show you how the flood inundation will be behaving. So I think once you've set up your model and it is well calibrated, and you are able to, of course, adjust other parameters as when they change in the catchment, then you should be able to quickly predict. And this is what the beauty that this tool is coming with, in that you need to only touch one button to give you results. Yeah. So if you want to see how inundation occurs, then you need to just play with the rainfall intensity. If I did this, then what happens? Yeah. And it is the kind of quick evaluation that we would want to see. Oftentimes, you get, as you said, in the climate change era, a rainfall intensity in a particular area, and they say, Waka has flooded. Yes, of course, we have the rain gauges in there. So from the gauge reader, it is a question of how much rain did we receive, in what period of time. Then you feed this into the tool, then it simulates for you. So if you are going to be looking for a response, like from OPM, what is the flood extent, then you should be able to simulate this as quickly as possible, and also propose or guide on the levels and the extent and what may need to be done in order to react to that flooding situation. So that is the beauty that it comes with, the ease with which you are able to evaluate the impacts of these things. Then Dennis, having to model this and find out the impact of these materials on groundwater, it is a good thing, but also it is not too much material. It is actually limited material that you will be using, and then we are saying it can be used for a period of 40 years, and thereafter, then one has to work out how it is fully assimilated into the soil, and then the properties within this material, whether they really have impact on groundwater. I guess some of these studies have most likely been undertaken. We are not privy to it, but it is an area that we can try to explore and see how the remains of these materials eventually find their way in water bodies. Any more questions or supplements, observations? If not, then I will invite Madame Gwendolyn Choburunj to close up this session. But on our side, as people who put this together to present to you, we are grateful for your insights. We are grateful for your time that you come to listen in. And we are grateful for the guidance and the clarifications that you've given on this presentation. It is a new technology in Uganda. It is something we are trying out. So I think the feedback is very useful, and we shall use it to have this better done and better implemented in Uganda. Thank you. Over to you, Madame Gwendolyn.
Thank you. Thank you, Assistant Commissioner. Thank you, Engineer Wogele. Thank you for the good presentation. I think I've been here listening in. And thank you for the participants for being active and being attentive and listening and getting to get what we do. And you know this is a new technology and being tried by the Ministry of Water and Environment through the catchment-based water management. And then we'll be able to have webinars, as it was at the beginning when the commissioner introduced this topic. The Water Resources Institute will always have monthly webinars, and these webinars we have people from different walks of life, researchers, practice, policymakers, students from academia, from policy, from practicing, from even government institutions, to present their findings, present their studies, present whatever that is in relation to water, environment, and climate change. to share and disseminate the information they have done. It may be a study, it may be a research, it may be just what has been analyzed and find what is coming in. And at this moment, we want to invite members who are present and members not present that please contact the Water Resources Institute. The email, I think most of you have attended, you have got an email from the Water Resources Institute email calling for you to attend this webinar. This is the 24th webinar since we started, and we wish people can come in, present their interest, that's called EIA, and then you present it to this, this email that was shared with you, and you'll be able to disseminate, you'll be able to share and hear the views of our partners. The webinars are not only for Ugandans, but even we have people who are on international ground that come and present their webinars to the communities within Uganda, within the region, and within the world. Please, we are welcome to submit your interest and be able to capture it and be able to present it to different individuals that attend these webinars. I would like also to thank those who have been constantly attending the webinars for the whole of this year, 2024. And we wish you a Merry Christmas and prosperous 2025. Bye-bye for now. Thank you. Okay, been hearing me? Hello?
Oh, yeah.
Yes. Merry
Yes.
Merry Christmas to you.
Merry Christmas to all of
Merry
you.
Christmas.
Okay,
Yes,
take
we
care.
have had
Bye-bye.
Madam Gani. Merry Christmas to everybody and Happy New Year.
Happy New Year. Thanks, Stephen. Bye-bye.
Bye-bye.
Bye.